Chapter 10, Constructions. Today we're going to look at similar triangles and a square. Your class opener, draw a right triangle and then copy it by side, side, side. Number 2, draw an obtuse triangle and then copy it by angle, side, angle. Today we're going to look at similar triangles and squares. Objective: after studying this section, you'll be able to construct similar triangles and construct inscribed squares and locate the center of a circle. Number 1 says, construct a similar triangle by the angle-angle method. And notice it just says similar. So similar means it has all the same angle measurements and that the sides are in proportion. So you could have a triangle that's larger or smaller as long as it has the same angle measures. So down below I'm going to construct a similar triangle. I'm going to make mine larger, so this will be the bottom of the triangle that I want. And since the sides are proportional, I really only need to worry about copying angles. So I'm going to start by copying the angle in the lower left of this triangle. So if I copy this angle, I know I make my mark. Oh, forgot to transfer my arc over here. Now I can measure how big the opening of the arc is. And once I know that, I can come over here. So I know that the side of the triangle will open up and has an angle like this, but I don't know how long it is, which is fine. Because now I'm going to come up over to the right side and I'm going to copy this angle. So first I swing my arc, copy my arc where I'm going to copy it. Then I want to measure how big is the opening of this arc. Transfer the opening of the arc. And now I've created a similar triangle that has the same angle measurements. The sides are in proportion. Number 2, draw a circle and inscribe a square. I'm given where the center of the circle is. So the first thing I want to do is just draw a segment that goes through the center. So I really want to draw a diameter for my circle. Now, if I want to inscribe a square, I know that a square, the diagonals are perpendicular and they're congruent. So I really just need to construct the perpendicular bisector of the segment that I just drew. So perpendicular bisector, I open my compass up to more than halfway, swing an arc from each side. And if I can connect those together, then I should know that the vertices for my square would be these points out where it hits the circle. And if I connect them together, I have a square inscribed in a circle. Find the center of a circle, method 1. So I'm going to show you 2 different ways to find the center. The first method is just draw any segment that has its endpoints on the circle. And then what I want to do is construct the perpendicular bisector for this segment. So to do that, I put the point of my compass at the end, open it up to more than halfway, and swing an arc. And I repeat from the other side. And I can draw the intersection in. And notice at this point, what I really have is the diameter for the circle. Well, I know that halfway across the diameter would be the endpoint of the radius, which would be the center of the circle. So if I just take this diameter and do the perpendicular bisector to it, then I should find the center of my circle. So drawing an arc from the end of each side of my diameter, connecting it together. And I now have that the center of my circle is right here. It's the midpoint of the diameter. Find the center of a circle method 2. So the second method starts off pretty similar. Draw a segment which has its endpoints on the circle, and just similar to before, construct the perpendicular bisector. So if I construct the perpendicular bisector here, I open my compass again to more than halfway, swing an arc from one side, repeat and swing an arc from the opposite side, and connect those together. And again, I can see where my diameter is. Now, different from the other one is just do the same construction again. And the only thing is, make sure that for your other segment, you don't draw it parallel to the first one. So any segment will do as long as it's not parallel to the first one you drew. And now construct the perpendicular bisector for this segment. So constructing this perpendicular bisector, same as the other one. I put the point of my compass on the end, open it up to more than halfway, and I'm going to swing an arc from each side. Connect them together, and I'm giving myself another diameter. And I know that all the diameters of a circle end up intersecting right at the center. So here should be the center of this circle. Closure. What's the easiest construction for you, and describe how to do it? What's the most difficult construction for you, and describe how to do it?